time to talk about binary tree. Now, there are many types of trees, but binary is often the most important in terms of interviews or like coding challenge and things like that. Binary tree is used in file systems. Usually the tree data structure is used in file systems, in search, in organizations charts, and in document object models. So if you are a JavaScript user, you know the relationship between JavaScript and HTML is something called document object model, which is a tree. And if you learn like how to make a binary tree, you'll have an easier time make other types of trees, and that will just make you a better programmer. Now, what is a tree? A tree consists of nodes and edges. Now, what's a node? Let's say we have an array of 1, 2, 3, 6. Each element here is a node. Now, the difference between array and a tree is one has a relationship with 2 and 3, something like that, which is through edges. Now, if I explain this through pictures, so we have a binary tree. These nodes, let's say these are, if I have a text here, 1, 2, 3, 4, 5, 6. Just to make it easier, like in programming, something like this. So 1 is a root element. The root element is the element with which has no father, no parents. Then each element has at least one edge. Edge is the relationship between the nodes. So this root node has a relationship between two other nodes, which is 2 and 3. Now, these nodes have a parent, one parent, and each node should have one parent. Now, the node 2 also have 2 children, which is 4 and 6, but node 3 has 1 children, which is 5. So what we do is, usually if it's a root parent, then there is no parent. You have left and right. So what's on left and what's on right. Because it's binary, the maximum is 2 nodes as children, no more than 2 nodes, but it can be 1 children. So here, like 1 has a relation with 2 and 3, 3 has a relationship with 5, but 2 has a relationship with 4 and 6. 4 and 6 on the left and right. So this is called binary tree, and this is very simple, to be honest, but it gets complicated at the end. Now, there are some terms to explain. We already discussed like what's a root, what's edge, what's parent, and what's children, what's left and what's right. Some more is path. For example, if you say like, what's the path to 6? Now, the path to 6 is one path from 1 to 2 to 6. So this is the path to 6. A sequence of nodes and edges from one node to another, that's called a path. Now, this is important because, for example, say you have a city map or something, you want to have a train station somewhere, then the closest path, you will like find out the closest path. So this is how you do it, like through nodes and edges. So height is the number of edges. Let me make it height. We have 2 terms, height and depth. So each element also has height and depth. What's height? Height is a number of edges until the leaf. So the height of root is 3 now, because the number of nodes, the number of edges until the leaf. By the way, leaf is an element without a child. So parent is root is an element without a parent, but leaf is an element without a child. The number of the height of any element is the number of edges until the leaf. So this has 2. Sorry, it's 2. But 3, the height is 1. What about, let me make it smaller if I can. What about depth? Number of edges until the root. So what's the depth of, say, root? It's always 0 because its root itself is like the depth is 0. But 5, the depth is like say, let me check, the depth is 2 but the height is 0 because there is this is leaf. So this is how you like just the terminology like height and depth, how do you define it, how do you measure it. This is both of them are 1. Basically height is to the leaf, depth is to the root, like that. And there's only one path between the root and any one node. Like 2, there's only one path. Between root and 6, there's only one path. There is no other path from 3 that you can get. So there's only one path between root and any node, including like leaf nodes. Even if you get more children here, like there is only one path between root and any node. So that's binary tree in terms of visuals. But how do we make a simple binary tree? Well, let's make a tree node. Now in the future videos this will get much more complex, but to make it very simple, this is a tree node. Like this dot value equals to value, this dot left equals to null, this dot right equals to null. Now this is a tree node. This is a valid tree node where we have value, we have left and we have right. Now if we say const a equals new tree node and a, now let's console.log a to see what we have. Now we have a tree node which left is null, right is null, but value is a. Now let's determine left and right. Const b equals new tree node b, const c equals new tree node c, a dot left equals to b, a dot right equals to c. Now if we check our tree node again, we didn't console it, console.log a. If we check that, a becomes a parent now because it has left and right, but it doesn't have any other parent. Now these are leaf nodes b and c because they don't have any children. So this is a simple explanation of a binary tree. In a future video I will make a better like binary tree as you see it more in coding assignments and things like that. So I'll make a better binary tree. Thanks.